a rectangular arrangement of numbers or functions, something mathematical, something non mathematical. For example, 2, 3, 7, -1, 2.5. It's a set of 6 numbers which have been arranged in a rectangular fashion. What could be the reason of arranging them like this is a secondary matter, but this arrangement is called matrix. I could have a matrix A, which is this. I could have another matrix B, that could be 2, -1, 5. I could yet have another matrix C, that could be 5, 5, -3, 0.5. Can you see how I'm reading the matrices? I could have another one which is 2, 5, 3, 2, 7, -1. Still, I could have a matrix like this: 2, 4, 7, 8, 9, 9, 2, -1. And let's say -2, -3, 0, 0. These are different varieties of matrices. Every matrix will have some rows and some columns. The arrangement that goes horizontally is called row. In the matrix A, there are two rows, the upper row and the lower row. And this arrangement that goes vertically is called a column. You can see that in the matrix A, there are 3 columns and 2 rows. So I can define something called the order of the matrix. The order of matrix A is 2 by 3. That is 2 rows and 3 columns. The order of the B matrix would be 3 by 1. 3 rows and single column. The matrix C will have an order of 2 by 2. I'm calling it 2 by 2. It's not our normal 2 upon 2. In the matrix language, 2 by 2 means 2 into 2. And 2 by 2 means there are 2 rows and there are 2 columns. Look at this interesting one. 1, 2, 3, 4, 5, 6. There are 6 elements arranged in a flat way. There is 1 row and there are 6 columns. Each of these individuals are creating their own columns. This one has 3 rows and how many columns? 4 columns. All of these are different examples. They are different orders. So orders of A, B, C, D, E are all different. We should have a knowledge of the order of a matrix if we are to do any operations on them. Do you think that this new example which I'm going to give you, is it a matrix? 5, 6, 2, 7, nothing, -5. Does this qualify as a matrix? The answer is no. Why? Because there's nothing here, not even 0. And you are not at liberty of putting a 0 here, because 0 is a bona fide element of any matrix, which is not given. So this is not a matrix. To be called a matrix, all the rows and all the columns need to be filled with elements. Let's talk about some very simple categories. Row matrix. Let's say I have a matrix which is a flat one: 2, 3, 7, -2. What do you see here? There's a single row. We don't have 2 rows or 3 rows. Whenever you see that there's a single row, you can call it a row matrix. Okay. We could have something called a column matrix also. Yeah. If you have 2, 3, -1, 4, let's say, this one will be called a column matrix. You have a single column. If you had 2 columns, you're not at liberty of calling it a column matrix. Okay. Then there is a special category of matrices called square matrix. Yeah, so you might have guessed it, that a matrix will look square only when it has equal number of rows, equal number of columns, and same number of columns. So if I say that I have a matrix which only has one element, 5, yeah, this is a square matrix, which because it has only one row and one column. Do you think this is a square matrix? 2, -5, 3, 2. Yeah, this is a square matrix because it is a 2 by 2 matrix. The previous one was 1 by 1 matrix. Okay. What about this? 3, 2, 5, 7, 0, 0, 1, -1, -1. Yeah, this is also a square matrix. It's a 3 by 3. So to be called a square matrix, they must have the same number of rows and columns. Now that we know about square matrices, the square matrices themselves could be of various categories. For example, there is something called a diagonal matrix. Imagine a matrix where we have it's a 3 by 3 matrix, where the leading diagonal has some numbers like 5, -1, 2, but all the non-diagonal members are 0, 0, 0, 0, and 0, 0, 0. This will be called a diagonal matrix. So in order to create a diagonal matrix, you pick up the leading diagonal, which is this diagonal. All the elements of these are non-zero. Maybe one of them could be 0, but essentially if you pick up all the elements, at least one of them will be a non-zero, but the non-diagonal elements are all 0. That's the condition to be called a diagonal matrix. All right. We'll talk about a scalar matrix. Okay. Scalar matrix is a further special category of diagonal matrix. Let's say we have 2, 0, 0, 0, 2, 0, and 0, 0, 2. Look at the way I'm reading the matrix. I read one complete line of the row, then I pause for a moment, then I read the next row, then I pause for a moment, then I read the next row. This is the way we read a matrix, so that if someone is just listening to you, they can have a fair idea what you meant. Okay. This is called a scalar matrix. So it's a special diagonal matrix in which the leading diagonal has all the same elements and everything else is 0. Now there's something we should know. It's called identity matrix. The beauty of identity matrix is that the leading diagonal has only ones. 1, 0, 0, 0, 1, 0, 0, 0, 1. This one is called the identity matrix. Sometimes we call it a unit matrix also. So the role that one plays in normal mathematics, that role is played by identity matrix in the matrix algebra. Identity matrix, this one is an identity matrix of order 3 by 3. You could sometimes call it an I3 also. So if we have I3, we could have an I4, we could have I5, okay, we could have I2 also. I can write an I2 for you, 1, 0, 0, 1. So identity matrix can take various shapes depending on the context of a question. There is something called null matrix or a zero matrix. Okay. What is it? All elements are 0. You might have guessed 0, 0, 0, 0, 0, 0. So a null matrix is not essentially a square matrix only. It can take any rectangular shape. it will be like 0 0 0 0 also. This is also a 0 matrix. Okay, so depending on the question that's given to us and depending on the context, we can create our own 0 matrix. Two more categories left. One of them will be called an upper triangular matrix. In which, let's say I create a matrix of order 3 by 3, where I create the diagonal first, 5, 6, -1. In an upper triangular matrix, we will see that if you create the upper triangle, which is this, upper triangle will have proper elements, but the lower triangle, the triangle made by the lower elements of the triangle, will have all zeros, which means that here it's 0, here it's 0, and this is also 0. While this could be a 2, this could be a 3, this could be a 9. This is the case of upper triangular matrix. If you see them without the shape of the triangle, it looks like this. Okay, so you can see that in an upper triangular matrix, in the upper side of the triangle formed, we have some figures, we have some functions or numbers, but on the lower side, everything is 0. Similarly, we have lower triangular matrix. What's so special about this? Here, as you might have guessed, let's create the leading diagonal, 2, 3, 7. Lower triangular matrix, on the lower part of the triangle we will have some figures like -3, 0, 2, but on the upper part everything will be 0, 0, 0 and 0. This one is an example of lower triangular matrix. All right, thank you.